is the right way of looking at the meteorological hazard of it. And there are different indices that combine these meteorological variables to show how what the fire risk or the fire hazard in that region is. And so in the case of the study in Australia, we actually used the Canadian Fire Weather Index because working together with the Bureau of Meteorology in Australia, we found that compares best with the area actually burned in these fires. So we have chosen that index, and then we have looked at observations of the different variables that we then use to compute this index, and also many different climate models where we looked at the different meteorological components, so temperature, absence of rainfall, wind, and so on, and computed this index. And we then asked, what is the likelihood of a fire hazard like the one observed or worse in the world we live in today? And then we compared that to what's the likelihood of this fire hazard of a value as we have observed it this season or worse in the world that might have been without anthropogenic climate change. And because we know very well how many greenhouse gases have been emitted since the beginning of the Industrial Revolution, we can remove these from the climate models and so simulate a counterfactual world. And by doing this, we found that in the case of the Australian bushfires, climate change made them at least 30% more likely to occur. And then we also looked into which of these indices were actually, or with which of these components of the index were actually most affected. And you can see a very strong signal in the temperature part of this fire index. But you don't see, for example, any changes in the likelihood of the drought component in that index. So in this case, most of the results that we have seen were driven by the sharp increase in the temperature. And now here is just a very brief slide to show that this is obviously Australia. And you can see in these yellow and red, this is where the severity of the bushfires in that season. And in sort of bluish, you can see where there are forests. Because before we actually look at what index to use or anything, we need to decide, well, what is the right time frame and what is the right geographical scale to look at these fires, because it could be that a fire season is very short and very localized, or here you can see that actually there are two parts of Australia where there were lots of fires, and we decided to focus on the eastern part because that's where most people live, and so where the impacts on the population are actually largest. But if we had looked at a different region and a different time scale, the actual magnitude of the result of our study would likely be different. It's because it really matters how exactly you define the aspect of fire that you can look into with meteorological data and climate models. And I think I'll leave it at that.
Okay, Freddie, thanks for that. So the second panelist is Dr. Anne Alencar, who is the Director of Science at the Amazon Environmental Research Institute in Brazil. So Anne, can you please tell us a bit more about recent wildfire trends in Brazil and to what extent we see climate change playing a role in these fires versus other factors?
Yeah, well, first of all, it's very important to understand that wildfires are very rare in the Amazon forest. Different from California or from Australia, there they have wildfires, bushfires. Our fires are mostly driven by anthropogenic ignition, direct anthropogenic ignitions, which are basically related to deforestation process. So, and this is very, very, very important to understand, because all the ignition sources that we have in the Amazon are man-made. So, and how that relates with climate change. Well, if we have an average year, like humid year, uh, and our dry season, which is basically the fire season, is gonna be, so the amount of fire that we have is going to be a reflex of how much fire people set. So if we have more deforestation, we have more fires, and maybe we also have more management fires, which are fires that people use to clean pastures. We call clean pastures, or to clean pasture from weeds and things like that. But if we have a very dry year, which is caused by some of the climatic phenomena, such as El Nino or AMO, which is the Atlantic multidecadal oscillation, or the North Atlantic oscillation, which are the main climatic event that have some effect on the dryness of the Amazon forest. So during these years, yes, we can have more forest fires, because we change that condition of the forest, of the rainforest, to act as a barrier for fires. Even in these years, if the climate is very dry, and if we change the condition of the fuel material, but if you don't have the ignition source, we won't have a fire, because there's no natural fires in the Amazon. So, and this takes us to the point that controlling controlling deforestation fires is the key issue that we have to do in the Amazon to control widespread forest fires. I don't know if you want me to talk more about it, but
no, that's great. Unless you have anything else you want to add now, or we can come back to this topic a bit later on.
No, I think it's only this. And this year, I mean, this takes us to last year, maybe, and this year. What happened last year? We had average year for the Amazon. We know that in the southern part of South America and in the other parts of the world, in Australia, that Dr. Freddie has talked about, but for the Amazon, we have actually a very average rainfall and dryness year. So that leads us to understand that actually the fires that we have seen that shocked the world were all like deforestation fires or pasture fires. We had some forest fires because we had more ignition, and also there's another aspect to that. If the forest is very degraded by logging, like selective logging, or very fragmented by a lot of deforestation, so the edge of the forest loses its ability to hold fire a bit. So you can have a little bit of wildfires there, or of forest fires there, because you change that relationship between the condition of the fuel material, the availability of the fuel material, the climate condition, and also the ignition sources. So those are the three major elements that takes the Amazon forest to burn.
Okay, thank you very much. So the next panelist we have today is Dr. Frank Lake, who is a fire ecologist of Indigenous American Indian descent from the United States Forest Service based in California. So Frank, from the perspective of yourself and the communities you've worked with, can you describe how wildfires have changed in the US, particularly in California, and to what extent can we say that climate change is playing a role in these fires versus other factors, including human land use and things we've heard about so far?
Yeah, so I want to think about California as being a very diverse climatic region, primarily Mediterranean type climate, cool, moist winters, warmer, hot, dry summers. And that's been the climatic norm for hundreds of years. But within that, there's the variation. And also for California, it's a very historically very linguistically and tribally diverse community of indigenous people. And with that, very diversified fire regimes And the notion that I'd like to talk about is the development of the cultural fire regime. And so, yes, we've seen here more recently trends of warming, drying, extending the fire season, more climatically induced fire behavior, but there's factors that contribute to that I really think need to be kind of unpacked and understood, particularly for different ecosystems across California that are fire-prone ecosystems that were heavily influenced by indigenous people prior to colonization by Spanish and the Americans. And with that, referencing anywhere from Southern California chaparral up to the far northern conifer mixed hardwood forest of Northern California, and from the coastal headlands to the interior higher subalpine environments, there is a gradient there of high probability of lightened ignitions historically, but with that, there's also, based on archaeological and other anthropological evidence, very high densities of indigenous people that were using fire across the landscape. Well, that diversified fire use by indigenous people that modified the frequency, the seasonality, the specificity, and particularly the way they wanted to manipulate the potential vegetation often tended to nudge that towards or move that towards more drought tolerant, fire adapted vegetation species that were of cultural importance. Some of the work in looking at the effect of climate, I would say was from Alan Taylor and Carl Skinner, had a paper that came out in Pinas regarding the extent of fires and the climatic effect. And they were showing that prior to Spanish colonization in the 1700s and then American settlement in the 1800s in California, at least, it was a more anthropogenic or indigenous fire regime or cultural fire regime system. And then with the colonization and settlement, there was the major decreases in indigenous populations through disease, genocide, forced removal, and then subsequently the Spanish had their first law enacted was to reduce or outlaw Indian burning. And then soon after that, the state of California in the United States with their fire suppression policies. What that did is, besides the removal of quite significant diversified indigenous ignitions, you then had a whole different culture come in that then valued fire exclusion and fire suppression, really demonizing or seeing fire as something as deadly or catastrophic versus being a fire dependent culture from the indigenous perspective that viewed fire as medicine. And with such, there was a cultural or stewardship responsibility to use fire to augment lightning and to promote that more diversified system. So when we think about like the work of Alan Taylor and Carl Skinner and showing that the system moved from being primarily indigenous driven to then being more climate driven after colonization, that's when you begin to start to see across many different fire scar records from the work done here for different chronologies, the increase in size of fires, the increase in patch size or size of those, but also in relation to being more narrowed into the lightning season. And then of course, with colonization and exclusion of fire, we have now over 100 and 150 years of buildup of lots of fuels, mass amount of forest densification, and now with exacerbated parts of climate, warming, drying trends, increased human density, then we have factors that all lead to there being more extensive fires. And according to many indigenous communities that I've worked or looked at ethnographic research, conducted oral history interviews with, that there has been many larger, more extensive fires that otherwise could have been prevented. And that's the nature of my work, is looking at the way in which indigenous knowledge can guide our fire research, but also understand fire effects. And looking at this perspective, this photo here of the Salmon River in the Klamath Mountains, we see a range of understory burn severities, but we also see the smoke. So we have this very diversified conifer and hardwood forest with the water. And for many of the indigenous teachings here amongst the Karuk and the Yurok and other tribes, is that relationship of lightning isn't producing the goods and services through moderating that fire regime, then it's your indigenous responsibility to step in there and to use fire to promote that. And particularly water is one of the most sacred attributes in this Mediterranean drought-like climate. And so by maintaining perennial spring flow, reducing tree vegetation that are essentially straws sucking up water that contribute to evapotranspiration, you use indicators. And I think that's an important part as a scientist when working with indigenous communities. We have our metrics that we measure, but what are the important metrics to that indigenous community? What are the indicators, such in this case, that would be aquatic species in the water, such as the salamanders and the salmonids or the salmon that are cold water dependent species, and linking the uphill or watershed fire effects to those aquatic species. And that's through those indigenous teachings, and that really frames the nature of my work here in California. So yes, we're seeing more extensive fires, but from many of the tribal perspectives, those are preventable by increasing the cultural fire regime and reinstating or revitalizing that indigenous fire stewardship. Thank you.
Thank you, Frank. So our final panelist is Dr. Christina Santine, who's a wildfires researcher from Swansea University in Wales. Christina, you study changes to wildfires both in the UK and in other parts of Europe. Could you explain how climate change is having an effect on these wildfires?
Yeah. Hello, everyone, and thanks, Carbon Brief, for inviting me to be here today. Let me just share my screen with you. Okay. Yeah, so I'm going to talk about the UK, and then later on we can discuss more about the rest of Central and Northern Europe, but I think many of the things can apply to the Atlantic Europe. I wanted to start with this picture because this is an important message, and this is that fire here in Europe, in the UK, is a human issue. So we have seen, like in Freddie and Frank, there are other climates that are prone to fire, but we definitely not have a climate or weather prone to fire. But we do have a lot of fires. Actually, the UK have around 30,000 fires every year, but most of these fires are really small, and they basically burn grass or heathland, as we can see in this picture. So we don't have these super intense and catastrophic and dangerous crown fires in forests. We don't have them yet. Just to show a couple of graphs, these are, I'm subtracting them from a report that British universities, together with the Forestry Commission at the Met Office, we are writing at the moment to inform the third climate change risk assessment of the UK. These are regarding trends or what has been going on with fires over the last decades. Well, we can't really say much because we don't have a lot of historical data of fire, because fire hasn't been seen as a big issue in these countries, in the UK and in other North European countries. So you can see these are annual area burned, number of fires reported by EFIS. So this is done by MODIS, so it's only picking up the fires bigger than 25, 30 hectares. Therefore, that's why we only have like a couple hundred of fires per year. Even if I say that we can have up to 30,000 fires, but again, most of them are really, really small. So yeah, we can see that we had a couple of the last years, we had more fires, but of course we only have a temporal record of 10, 15 years, so we cannot say much about that. What we can say, however, and these are some predictions based on, as Freddie said, these are only based on climate. These were made by Matt Perry from the Met Office for this same report that I mentioned earlier. So the UK is already feeling the effect of climate change. So we have an increase of warm spells over the last decades or so. And if we go into the future, we'll see that the fire weather index, again, this is the Canadian fire weather index that Freddie mentioned. So we see that the numbers of days during the year where we can expect a higher fire risk in terms of weather increase in the next few decades. However, I would just like to end with this slide that I really like, because we cannot, whatever we are seeing and whatever we'll see, we cannot only blame it to climate change, not especially in Europe, because the fire is going to be a result of the interaction of weather, of human ignitions. I forgot to mention that here, practically all our ignitions are human, either by accidental causes or by arson. So how is going to change these ignitions, and very, very importantly, how our land uses are going to change or are changing, because that's also going to affect the fuel availability and the spatial distribution of fuel. So not only climate change. So I think I will stop here now. Thank you.
Thank you very much. It was very interesting to hear from people who have expertise in different parts of the world, but there's some common themes emerging to do with how human influence in terms of deforestation and things like that kind of overlap with climatic changes. So what we're going to do now is we're going to pass it over to answer some of your questions. I can see that already quite a few questions were coming in. So Leo, I think you're going to start us off with the first question from an audience member.
Yes, thanks Daisy, and thanks to all the panelists. Yeah, we've had some fantastic questions pinging in. In fact, it's quite hard to choose between them at the moment, but why don't we start with this one, which is being directed at Freddie by Dr. Will Howard, who's a climate scientist working with the Australian government. And Will is asking, how close are our Earth system modelling capabilities to being able to incorporate factors such as fuel quantity and conditions into the modelling approach utilised in the Australian bushfire attribution study?
That's a good question. And I think, so what the models definitely incorporate and can incorporate is the type of land that is available. So whether it's forest and what kind of forest, but of course not exactly the amount of fuel in a given year. But I think what we have seen in these studies that we've done in Australia is that the models are actually really underestimating the effect or the increase in temperature in these smaller localized areas where fires start. So I think that indicates that all the estimates that we have in terms of the increase in fire weather from a climate change point of view are really conservative estimates. So and I think improving models to get the climate feedbacks right is probably a more important research question before because I think that the fuel availability and other aspects like that is conceivably that you can do that with not within the same model, but sort of as an additional step.
Okay, thank you, Freddie. Daisy, have you got another question?
Yeah, so I've got a question from Mary Huffman, who is a director of Indigenous Peoples Burning Network and Fire Science at the Nature Conservancy. So this is two questions kind of wrapped into one. What is the role of Indigenous people in bringing wildfires back into balance? And what is Indigenous fire stewardship, and how can non-Indigenous people support it? So Frank, I know you've already spoken a bit about this, but would you mind taking this question? Thank you.
Yeah, so in a contemporary context, I think it's important to acknowledge Indigenous, or in our case, California, tribal sovereignty as being part of the governance structure when it comes to incident management teams for managing wildfire. And here in the US, we have the National Cohesive Strategy for Wildland Fire that has three components, such as resilient landscapes, fire adapted communities, or what I'd say fire dependent cultures, and safe and efficient wildfire response. And in that context, linking policy and governance down to operational aspects on the ground and working with Indigenous people is a way to acknowledge, one, their role and place in that fire-prone ecosystem as a fire-dependent culture. And that links back to the Indigenous fire stewardship, which I'll talk more about. But in that construct today, and I'd also might add in my work as a federal scientist, but also as a resource advisor, often serving as a lead resource advisor on large fires here, working with incident management teams over the last probably 15 years. This structure of having government agreements with Indigenous communities, have designated tribal representatives that engage, that work with incident command team and the strategic management of those fires. We also talk about wildfire management having we call it incident action plans, having objectives of that day And many of those objectives in this area, because of the larger population of indigenous or tribal people, often reflect natural cultural resources as well as fire personnel, and public safety. And so in that operationally, including indigenous people into that wildfire planning, but also as well as managing wildfires to achieve your resource objectives, that's one way of bringing in that indigenous fire stewardship. It's a model that I've tried to have other indigenous communities, whether it's in Australia, other places, to be aware of. Again, back to this kind of colonial fire management model system, the U.S. Incident Command Teams has had that model really brought all over the world. I know, like when we had large fires here, Australians came here, incident management teams. Likewise, our fire service went over there to support them this past year in the brush service. But what I didn't hear was the opportunity to engage those Aboriginal or indigenous communities more directly, like we have here in Northern California. That's a government-to-government agreement process that brings them into that management. But on the pro side of fire risk reduction and hazardous mitigation and working in around communities, is that indigenous fire stewardship, often trying to achieve, again here, promoting those drought-tolerant fire-adapted species that then allow the ability to manage fire either on your terms at less climatically volatile or severe conditions, diversifying that seasonality, so burning actually different vegetation types in the cold, dry periods of our winter, but also perhaps more extending that fall season. And then what that does on the proactive side of using prescribed burning or cultural burning is that reduces the fuel loading, reduces the risk of the future fire. And so we often think about deferred risk by suppressing fires right now actively to protect life and property. There's trade-offs and working with indigenous communities to think about the opportunity to manage fire to achieve resource objectives and to protect life and property. There's that opportunity to explore the ways in which that indigenous knowledge can inform the governance and the management of fires to achieve, again, a range of values that we want, but really also promoting in many areas of our fire-dependent species and vegetation, reintroducing that fire for cultural and socio-ecological objectives. Thank you.
Okay, thank you, Frank. So we have a question here directed to Anne, but I guess anyone can respond as well after Anne. But this is from Shigeru Watanabe Jr. And the question is, could you say something about the fires during the last strong El Nino event, which I think, Anne, you've already touched upon, but were there more fires at that time and did they affect pristine forest areas?
Yeah, and the last El Nino that we had, it was a very strong one and very long as well. Started in the end of 2014 and ended in 2016, but we also faced a lot of fires in 2017. So it's not what we have seen, that when we have such a long climatic event that causes very extreme droughts during the dry season and also affects the recharge, I mean the wet season consecutively, the next year, which was 2017, we have more fires, a lot of fires in the Amazon and a lot of forest fires in the Amazon. So even though our deforestation rates were kind of increasing that time, but much lower than what we have now, but a lot of areas were burned because we had this very strong event, consecutive dry season events caused by a very strong El Nino. So this is one of the major impacts also of climate change, because it is affecting the climatic phenomena. And we tend to suffer with that. And I remember that the people from NASA or UC Irvine put together, how can I say, a predictive model to indicate the drought, how is going to be the dry and the risk of fire in 2017. And they had predicted a lot of fires because of the El Nino. And in fact, there we had a lot of fires, but 2017, we had more fires overall. So I think my message here is that the year when we have the climatic event is very important. But if we have consecutive climatic events, the following year, if we don't have, even if we don't have El Nino or other climatic event affecting the dryness of the Amazon, the recharge during the wet season was not sufficient actually to how can I say, the vegetation is under a very stress, like hydric stress. So we can have consecutive, how can I say, impact of these events.
Thank you very much. So now we've got a question from Graham Craig, who's a senior policy advisor at the Welsh Government. He's asking, are there any studies or is there much research around that can tell us about the difference between wildfire risk in Wales and the wider UK under 1.5 degrees of warming and 2 degrees of warming? So Christina, I'd ask you to talk about that if you can.
Yeah, well, that's a tricky question. South Wales, so I'm based in Swansea and it's South Wales. That's where especially this spring, the highest number of fires happened. We have a lot of fires and we have a lot of arson fires. So many of these fires are not accidental. So it's really complicated because again, yeah, we can try to predict how weather and fuel availability is going to increase with the trending warming of the climate, but we don't know how society is going to interact with us with that climate change. So saying it in another way, we have lots of ignitions, and as I said, we had 30,000 per year. So yeah, 30,000 per year. In the UK, we have around up to 10,000. We can have up around to 10,000 per year in South Wales sometimes. So if we have a warmer climate, we'll have more fuel available to burn, but then we don't have lightning. So all our fires come from people. And in South Wales, most of them, or many of them, we don't really have figures, but most of them come from arson. So so that's why I said earlier that it's really, really important to look at the social, economic aspect of fire, especially here. Thank you.
Thanks, Christina. So we have another question here it's come from Indonesia, and it's from Zara Kurniawati. And the question is, almost each year in Indonesia, there is always fires that are happened or caused intentionally by some corporates and companies to free the land for their own profit, which causes terrible damage to the countryside. Do any of the panelists have any research into this? And I suppose the question is asking, how do you separate out the separate causes of certain fires? So do any of you have any thoughts on this question on this kind of separating out different contributing factors? And maybe if anyone wants to speak particularly to the situation in Indonesia.
I can comment how we are trying to do that in Brazil. And
okay.
So, first of all, most of the fires, 100% of the fires are set by someone, and they are set intentionally to get rid of the 300 tons of biomass that is chopped down of forest and have to be burned to become nutrients to the soil to set some pasture or agricultural fields. So the second type of fire, so this is the first type of fire. The second type of fire is the fire that is set in areas that were already the forest in the past and became pasture fields or agricultural fields that need to be cleaned from weeds or things like that. So those are the most common types of fire in the Amazon. The third type of fire is the forest fires that occur in a very specific conditions, very driven by climate, so climatic phenomena, and also they need ignition sources. And the major ignition sources are the two that I mentioned first, the deforestation fires and the management fires. So those are the two major ignition sources for the forest fires when we have very dry years. So knowing that, we know, I mean, by overlapping with satellite, how can I say, maps of land use maps, we know what is burning. We know if forest is burning, if it's a recent deforested area burned, or if it's pasture fields that is burning. So this is one part. But the second part is to understand who is burning. And for that, we cross with tenure data, land tenure data. So we know, for example, that half of the fires that we had in the Amazon last year and half of deforestation that we had last year happened in public lands, in Brazilian public lands, due to land grabbing. So, and the other half, a part happening in private properties, the other part happening in smallholder settlements. And so by doing that, we know who is setting fires, where these fires are happening, and in which land cover is burning. So we can understand the processes, and we understand how to fight those fires. And just to finish, so if half of the fire is happening in public lands, done by people that want to grab public lands, like criminals take Brazilian land for themselves, those are per se illegal. So, what to do for that? I mean, you have to go and have police force. Enforcement is going to fight that. The other part of fire, which is the management fires in already open areas or deforestation fires that can happen in private properties, we have to deal with incentives, positive incentives to reduce the use of fire. So those elements solutions can only be said and implemented if you know which types of fire are happening where. So I don't know if I helped, but this is what we're trying to do in the Amazon.
Okay, thank you. Another question from Brian McHugh. He's asking how are fires in the Arctic impacting the global picture? Freddie, I know you recently looked into how climate change could be influencing the heat, not the wildfires themselves, but the weather that can sometimes promote wildfires. Do you mind talking a bit about that analysis?
Yeah, so I think there's definitely a huge difference in the fires that we have in tropical rainforests than fires that we have in more temperate regions or even in the Arctic. And I think what we very clearly see and very, very strongly in the Arctic region is that of all the weather components that are important for fire, climate change is a huge game changer in the temperature component. So, and if everything else is staying equal, but we have this huge change in the extreme temperatures because of climate change, then of course that increases also the risk of fires. And we have seen that in countries like Sweden, for example, where colleagues have done attribution studies on the fires there, and where we see that. But I think that everything else being equal is of course not necessarily always the case, and you have to take the other factors into account if you really want to predict the fire burning. So for example, in the Arctic, because of the increasing temperatures, also the vegetation is changing, and so actually you have and there is and you've seen in recent years more rainfall and more snowfall. So actually that is sort of dampening the fire risk a bit. It's in terms of the magnitude of change, it's totally not outweighing the temperatures in the Arctic regions. But I think for the individual areas you want to manage, or you're interested in, and you want to see these factors become increasingly important. Whereas you can say in the broad picture, we have this huge temperature signal, and that definitely makes all the other signals much smaller in these more temperate regions. But if that also is, if there are not other factors outside the climate system or in other drivers that are really important for the area that you care about, or that one wants to manage, I think it's harder to say something with these very broad brush that it will get worse.
Okay, I think Christina wants to come in.
Yeah, I just wanted to add to what Freddie said. I think the question was also about how fire can affect a climate, and I think it has been a lot of interest recently because of the so-called zombie fires. And the Arctic and also the boreal regions are really interesting, and I would say scary in that way, because their soils accumulate a lot of carbon. That carbon is very, very old. So some of it is in peatlands, and we also have tropical peatlands. But in the northern peatlands, this carbon is protected from fire because those don't tend to burn a lot. But if we see an increase in fire in boreal regions and Arctic regions, as we are seeing already, some of that carbon is going to go into the atmosphere and can contribute to the carbon, the climate change. Also, it's not only CO2, it's methane. Also, the fires have an influence in the thawing of the permafrost. So as Freddie said, it's super complex. It's a super complex system, but I think it's interesting to know also that they are really bad, if we can say, regarding climate change.
Okay, thank you, Christina. We have a question here from Wisdom da Costa, which is possibly one for Frank to take on in the first instance, is what can we do to reduce the risk of forest fires in different parts of the world?
Well, I think part of to reduce the risk of the non-desired wildfires, we have at least the US model here again in California, is to look at areas where you've had fire excluded and look at the intervals that have been missed. So we have a formerly frequent fire-prone ecosystem that's burned every 10 years on average between lightning and indigenous ignitions that now hasn't seen fire in 100 years, then we've missed 10 cycles. And so part of that also has led to the densification of trees that increase the fuel loading, both from the surface to the ladder and canopy fuels, that now really are, when it's extremely dry and desiccation and those fuels dry out and there's other factors that affect that fuel continuity, then we're going to have those larger, more extensive fires. Now, there is some debate about the best way to reintroduce fire. I would say a lot of my government-based studies looking at thinning the forest, so promoting aspects of fire-resistant, drought-tolerant trees. So those are often the larger, in our case, would be some of the larger hardwoods, conifers that are more fire-adapted in their life history traits. Promoting what we call also heterogeneity or diversity amongst those forest types or other grasslands and shrub systems. In many cases, there used to be much more formerly extensive grasslands, prairies, and meadows that have now actually increased in tree density because of the absence of fire. And so we think about also prioritizing those areas strategically to get that complex early cereal habitat that adds a lot of other diversity in our understory plants and shrubs and communities in that way. Also, again, that factor of thinking about reducing evapotranspiration or the amount of tree density that's utilizing water that affects our perennial springs and streams and creeks and rivers. So in that regard, promoting those fire-resistant tree species, looking at opportunities to increase fire use by reintroducing it perhaps on what we call the shoulder seasons, or areas that aren't the wildfire most hot and extreme times. And then with that, the maintenance. I think so many times in our collaboratives, we see government entities or state entities working with non-governmental organizations, or our case, like the watershed or fire safe councils, and tribal governments as a collaborative, looking at broader landscape restoration across jurisdictions. That's an important part of that, is to work across what we call all lands, all hands. If you have one, say, private property or an adjacent public land that isn't being as actively managed to reduce the fuels, to reintroduce fire, then you have those adjacency factors. And really fire, especially these larger fires that are more climatically driven now with large wind events, in our case in California, you need to have effective treatments across the landscape and across jurisdictions. And part of that, you have to really work on what are your shared values, what are your strategies for looking at fire at different scales, and an opportunity to reintroduce fire. And particularly in our case here, that's looking at areas that were heavily influenced by cultural fire regimes, as well as lightning, and then reinstating those types of diversified burning to reduce fuel continuity, and reducing the fuel continuity, increasing a lot of that, again, heterogeneity or diversity or mosaics between recently formerly burned areas. Then you have those barriers to fire spread that then allow you to either suppress that fire when it's burning under severe conditions to threaten life and property, and to protect public resources, or to be able to manage that fire to achieve a range of objectives where fire is a necessary part of that environment, socio-culturally as well as ecologically.
Is there anyone that would like to add to what Frank said to that question? Okay, so moving on then, we've got a question from Alejandro Fernandez, and he's asking, have paleoproxy methods informed our understanding of what fires are like today? I think, Frank, you'd probably be able to answer that question as well, and maybe other panelists.
Yeah, I think we have to look at the availability of the science methodologies we have. So in the more physical science, we have the paleoclimate studies that often look at lake or pond cores, of looking at the chronology there that articulates the amount of charcoal that is a metric for fire episodes, as well as the pollen assemblage, which would represent those species that are more, say, fire tolerant or intolerant, that also represent dry and cool periods. So we can use that, but often that resolution in the lake cores are not very, like, at the scale, the more decadal, and they can't really get down to year precision chronology. So you see broader trends across decades with even the finer amount of paleoclimate, looking at the pollen and charcoal assemblage across elevations, areas. These aren't, high elevation lakes, but even lower elevations where possible. So you get a broader landscape signature of the trend climatically, as well as fire episodes in the area. And then you cross-link that to the dendrochronology of the tree records. Often in our case, we have pines or cedars that are going back several hundreds of years, sometimes almost 500 or 600 years for those longer lived species. And when you chronology that, you can see the effect of fire there, both in seasonality by the ring scar boundary, but also in the frequency of fires that burned in that area. And that helps guide partly what was that occurrence of fire. Now, the specificity is harder, and to say, well, was that a lightning ignition or was that an indigenous ignition? We then use multiple methods, interdisciplinary methods, looking at archaeological information, oral history reviews, talking to elders, tribal indigenous people there, to say, what were the areas of the landscape that you more frequently would use with fire, and have more specific of your own cultural objectives versus maybe the high probability of lightning in certain aspects of higher elevations or during a certain season. So that's the one way we can kind of disentangle that. And I'd say now, using those more interdisciplinary methods, we're able to kind of disentangle the anthropogenic versus the natural contribution of ignitions. And that also helps guide perhaps where we need to more actively use fire or reintroduce fire, kind of on that cultural versus ecological justification.
Okay, thanks, Frank. We have a great question here, actually, from, I'm going to even pretend to pronounce his name correctly, Avilo Hybarov, who has asked a question, which is, just to paraphrase it slightly, if countries try to expand forests and bioenergy crops as part of their own climate mitigation strategies, could this put even larger areas of land at risk of fires? Does anyone want to take that on?
Yeah, this is Frank. So we have a case here where there's the carbon offsets and the funding that says, you know, if you can grow denser forests and sequester carbon, then you'll be able to have monetary offset for that, for essentially having those forest reserves. The trend we see here in more temperate forests is what is the expected vulnerability or risk to that forest over that 100-year life cycle. So in our case, we have Douglas fir, fast-growing conifer, that often is an important timber species tree. If we're now growing that not for timber or board feet, but we're growing it to sequester carbon, it can be on highly productive soils and areas of the landscape that you're managing as that reserve. But then now, because of the density and the homogenization or the single species that you're growing, it's now predisposed to drought stress from extended climate warming. It's now higher fire risk. And so you actually have a less resilient, but maybe more carbon rich storage part of your landscape in that forest condition. But I would say in many cases, we might want to diversify that and perhaps sequester a little bit less carbon, but still having a higher rate, but increase the resilience and the resistance of that area to help mitigate or prevent the effect of drought, fire risk, and insect and disease on that stand. Because again, over that 100-year life cycle, you may be able to sequester so much carbon, but it's also highly vulnerable. And if you get to your 80th year and it all burns up, then we've highly volatilized and just lost all that investment.
Okay, I think Christina, you had your hand up, I think I saw.
Yeah, sorry, I went for the traditional way. But no, I completely agree with Frank, as in the UK, there is a lot of talking about rewilding now. And I'm not going to get into that discussion, but of course, we need to be very careful with the type of trees we want to have. So any native, at least here, any native broadleaf tree is not very fire prone, and those areas will be not very fire risk under the current and in the next couple of decades. But whatever conifer plantation we have, we need, as Frank said, when we are putting all the socioeconomic factors together, we need to have into account that they can get riskier and riskier regarding fire in this trend of a warming climate. Thank you.
Okay, so we've got a question from Karen Cofield. She's asking, in future climate projections examining fire frequency and intensity, are there estimates of the carbon emission feedbacks that can be attributed to these increases or decreases? So it's a question around, to what extent can wildfires cause or drive a positive feedback for climate change? Is there any panelists that would like to answer this question?
Can I try, or at least start?
Sure.
Well, in the Amazon, as I said before, I mean, fire is a rare, like forest fires are rare events. So in the forest is not, the trees are not resistant to fires, like the bark is very thin and things like that. And the understory fires that they go very, even they are not intense, they are like this big usually, and they go into the forest and they burn slow, so they kill the trees. Some research from the people from Lancaster, led by Joss Barlow, they have indicated that after 10 years of a fire event, you still have, like, the forest is still emitting carbon from the mortality of the trees done by these fires. And some of the regions, some of the areas that we measured, like the impacts of one, two, or three fires, we had up to 50% less biomass in the standing forest. So it's a major impact on the Amazon forest that has not been accounted in our emissions, greenhouse gas emissions accountability. And we are putting together a set of scientists to do that. And I think we will be very surprised on the effects of these rare events on emissions, greenhouse gas emissions.
Okay, thank you. I think we've only got a couple more minutes left, so let's try and squeeze in one question if we can. So this question is from Caroline Koch, who is asking, even if the causes of the ignition of the fires can be attributed to humans and not blamed on climate change per se, is it possible that fire weather conditions are changing and are favoring the spread of wildfires once ignited? And it kind of leads on to a sort of wider question that a few people have asked is, can we tell what the proportion of fires ignited by people compared to, say, lightning are? People are kind of quite intrigued about this, the way that we can actually attribute these different factors. I don't know if anyone, we've only got literally sort of a minute or so left. If anyone wants to take that on.
Yeah, here in the US, we have using satellite imagery and other fire detection, you can see where lightning strikes are for the positive strikes. And then you can compare that lightning strike density data set from that imagery to then where there's the anthropogenic ignition. So that's one way to disentangle those. The other thing is then to look at the seasonality, or when those fires are occurring, or what part of the landscape under different meteorological conditions. But to that effect, we are seeing an amplification of the foehn or the dry east winds that are driving fire behavior here, particularly from California. And that is problematic in the sense that if there's fuel there, it will burn. And if it's hotter, drier, and more intense winds, then we're going to have severe effects after high intensity fire. So we can likely disentangle what type of ignition, but where that occurs and how it occurs is often wind driven, and those are becoming more extreme.
Okay, thank you. And final word to Freddie, I think, who's got her hand up.
Yeah, I just wanted to say that yes, we can say in many parts of the world that and we see in many parts of the world that if there's fire weather conditions, then it will burn, and there will be some ignition will happen, and that's not in all parts, not in all forests, but in many parts of the world. So we do see that, and there we can say for, especially for the temperate forests and Mediterranean climates, where we see also drying and an increase in temperature, we can see that also the risk of fire weather does increase with climate change. And also, I think what Frank was saying, that's important, that the seasonality changes, and that has a huge impact on the extent and intensity of the fires.
Okay, well, sadly, that's our time up. And I just want to say a huge thanks to our panelists in the first instance, and also to all the people who've been sending in these excellent questions, and also to my colleagues, Daisy, obviously, for chairing the discussion today, and also to my other colleagues, Rob McSweeney, who behind the scene has been helping with sort of going through these questions, and also the sort of technical whizzes, Rebecca, Daniel, and Joe Goodman, who've also been helping behind the scenes with the YouTube live stream. But just want to say big thanks to everyone, and this recording will now be placed on YouTube within a few minutes, I think. So again, many thanks, and great discussion. Till next time. Okay, bye. Thank you.